Hello, everyone. Welcome to this week's webinar titled Shed Light on the Dark Space, Close the Gap to Achieve Total Network Visibility with East-West Traffic Monitoring. The next webinar we have is scheduled for May 15th, and the topic will be around Wireshark visibility with Skylight database decodes. We hope you will all join us then as well. So our presenter today is Mike Canny, our resident business development guy. Over the past 28 years, Mike has helped hundreds of companies identify and resolve their application and network performance issues. Mike has also developed coursework and taught engineers how to identify, remediate, and prevent network and application issues by analyzing traffic flows at the packet level. Mike has been a guest speaker at many industry shows such as NetWorld, Interop, Wireshark, SharkFest, and Cisco Networkers and Cisco Live throughout the United States on the topic of application performance analysis. Today's webinar should last about 30 minutes. We would appreciate if you could keep all your questions until the end of the presentation, where we will hold a short Q&A session. If you do have questions during the presentation, please feel free to use the question box found on the GoToWebinar dashboard, and we will make sure to answer them. We would also like to let you know that this webinar is being recorded, and if you need to drop off at any time, be assured that we will be sending you a link to the full recording. Now over to you, Mike.
Great. Hey, thank you, Yasmin, for the introduction, and thank you, everyone, for joining the 30-minute webinar today. So as Yasmin mentioned, we're going to be talking about looking at those gaps or those blind spots that many organizations have within their visibility architecture, and primarily understanding of the different solutions that you can take to fill those gaps, and specifically the east-west traffic. So what does this whole north-south, east-west traffic mean anyhow, right? So what I've got here is kind of a diagram of what I see from a consulting perspective of what we call traditional packet-based monitoring, right? Where we're looking at all of the traffic as it traverses the wire. Typically, we're using a TAP or packet brokers via span or mirror ports that are looking at all the traffic inbound and outbound. And some of the disadvantages of this, as we've moved into more of a virtual network space and cloud network space throughout the industry, is that typically with this looking at the wire perspective, all we're going to see is that first tier of traffic. So from this perspective here, as we go into virtual servers, hypervisors, VMware, etc., one of the big gaps that we're going to see is only this first tier, that end user traffic. So as applications have become more distributed, multi-tiered, multi-location, relying just on this wire type networking today, or wire type tapping, is really no longer sufficient. So if we look at what we're talking about really with this north-south traffic, and some of the benefits of this is we are going to see all the user activity. We're all going to see all of the end user traffic, having the ability, depending on the analyzer in question, to essentially go back in time. So, for example, a problem happened yesterday at 3 o'clock, being able to drill into that, see exactly what happened from that end user's perspective. With this traditional north-south visibility, though, especially in the virtual environments, where you've got maybe a simple pre-tiered application, a client going to a web server, going to the backend database server, the only traffic that you'll see in this north-south environment is the HTTP requests or the calls made directly to that web server, to that application server, and can sometimes be, and we'll see when we get into the demo here, sometimes a little bit misleading as to where the bottleneck exists, right? So, for example, if we see an HTTP GET that goes into the web server, and we're watching the traffic of the packets as they go in and out, and we receive that reply to that GET 20 seconds later, from that analysis alone, it would potentially indicate that, hey, we've got a slow web server. But what we want to do with filling these visibility gaps in the east-west traffic is being able to see, okay, what did that web server do on that back end? What calls did it make? And was it potentially waiting on something on the back end? So if we look again at some of the potential problems as we move into a virtualized environment, and we break in and break apart that specific hypervisor, what we can see here is, again, in that multi-tiered application, we've got web server, or clients going to a web server going to an app server potentially going to a database server. And even in this simplistic view, if we're tapping in that north-south, or we're spanning in that north-south environment, all we're going to see again is that client to the web server. So all of the additional calls back from the web server to the app or to the database server is all going to be abstracted to our capture and to our analysis. So what we really need to do is look into that system itself, into that hypervisor, and tap into that virtual switch, right? So we can actually get that traffic, monitor that traffic, and there's a couple of different aspects of how that occurs in the world of networking today. And this is typically what I see as a consultant, kind of traveling around doing the troubleshooting processes, is that a lot of environments, if you want to see that VM to VM traffic, most of the recommendations from a lot of different vendors are to go back to each individual hypervisors, right? Each individual ESXi server, and actually, insert or deploy a dedicated NIC. In most cases, that's, retrofitting the server to a 10 gigabit per second NIC, then communicating that back to a packet broker, which then your capture appliance sets off of, or any of those tools that need to see packets. The big problem with this, the big obvious problem is the intrusiveness of this, right? In this environment where you have to go back, install a dedicated NIC, not only is that downtime, but it's also quite expensive. And I've seen in a lot of organizations, especially, when you're talking about 100 and up virtual servers, not only the cost of the NICs themselves, but also the ports that are required on the packet broker, quite expensive. So this solution really isn't scalable. And again, when we start talking about visualization within the public cloud or infrastructure as a service, again, not a solution for that. So what we've done at Excedian is kind of taken a little bit different approach, right? So our visibility within the east-west environment essentially is a virtual appliance, right? So we have virtual capture capabilities that actually will sit as a VM on the hypervisor and watch the inner traffic of that virtual switch. So in the case of where we've got, 10 gigabits per second in the last example, we don't need an additional NIC for this specific visibility. In fact, the communications that you see here between the capture appliance for the capture VM and the PBX data store is actually a very thin stream of metadata that's being sent, right? So we're not trying to replicate all of the packets back to that device. We're actually sending about 0.2 or between 0.2 and 0.5% of the overall observed traffic. So in the advent of monitoring at 10 gigabits per second, that's typically about 2 megabits per second of overhead that's added, right? So very, very thin stream, very lightweight, scalable, and, as we say here, 100% based on the native architecture, right? And the other huge benefit of this is the time to deploy. So essentially, we can fill these visibility gaps in east-west traffic in a matter of seconds, right? So it literally takes about 30 seconds to install, deploy, and be up and capturing with no changes to the architecture, no changes to the infrastructure. So what does this mean for visibility, right? And those visibility gaps? Well, essentially what PBX does, for those that might not know, is again, we're relying on wire data, right? So we can see that in that traditional north-south environment via a tap or a mirror port. We can also see that in a virtual environment. And what PBX is doing is it's listening to every single transaction, 100% of the user transactions, 100% of the application transactions, and decoding that in real time. So those transactional thread level protocols such as SQL, Oracle, HTTP, SMB CIFS, are all decoded in real time and then accessed so that you can look at that data in real time or forensically, depending on when the problem occurred. So what I'm going to do now is I'm going to jump into a specific example of looking at east-west traffic and looking at just the north-south traffic, for example, and showing some of those pitfalls there may be if you're just looking at north-south traffic. So what we have here is this is the troubleshooting interface for PBX. And what we're looking at here is the business, what we call the business critical applications, right? So these are end user defined. You can see here we've got the Oracle DBM. We've got this ERP front end, ERP back end. And just kind of as it sounds, we've split this ERP application off into its multi-tiers, primarily for very quick triage, very quick analysis. So if we look at specifically the ERP front end, and again, this application is a 3-tiered app. It's a client to a web server to a back-end database server. Again, very straightforward application. As I mentioned, we're looking at this traffic in real time, but we're also keeping and retaining back in time, right? So, for example, if the problem happened last Monday at 11 o'clock, I can simply come in here and show me everything that was going on, last Monday for this application from 10:55 to 11:15, and boom, it'll show us that traffic. Likewise, I can come in and look at the real time and say, hey, show me what's going on in the last hour, last 15 minutes. And then what this does is it's plotting out that end user's experience, right? You can see we're changing from green to orange to red, but essentially every 1 minute interval, we're recording that specific time period. So, for example, as I mouse over this 1 minute interval from 9:05 this morning, we can see a bunch of statistics, a bunch of numbers that show up here, specifically breaking down the components of the delay, right? So the EURT stands for end user response time. So essentially that's the time that user hit enter to the time that they got their screen back. And in this case, we can see it was 7.6 seconds. And then we've got the different components of delay underneath of that end user response time. So we've got the round trip time, both from the client and the server's perspective. We have the SRT, which stands for server response time. And we have the DTT, which is essentially the data transfer time, right? So the network impact or the in-flight traffic. And so what's really cool about this is from a triage perspective, if I were to be a help desk or service desk, I can come into this specific period here and either, whether I was alerted to this or I was following up on a help desk ticket that came in, I can see right away where the bottleneck is, right? Who does this ticket need to be assigned to? We have a 7.6 second end user response time. 7.2 of that happens to be the server delay. So how we're calculating that again is we see the request go into that first tier, we see the reply go back out. That delta is going to tell us what that server time was. So from here I can drill into this and say, hey, show me the totality of all the end users, right? So what this is graphing out here is every single user that's running this application. Again, 100% of the traffic. We're not doing min-max averages or 95th percentiles. We're watching everything. And one of the things that you can see here is that around that 9:05, we had an average response time during this period of time of a little over 6.5 seconds. And again, it's color-coded based on what comprised that, right? So if I were a network engineer and I wanted to see what the network was responsible for, I can simply just unclick the server time. And I can see at 9:05 when I had my end user problems, that the network was only responsible for around 500 milliseconds, right? So it's very useful, again, to be able to come in very quickly, triage where those bottlenecks are. Down below here, it's going to show us the servers that were involved in this. And more importantly, over here, the zones or the remote sites that were experiencing the worst performance problems, right? So we can see right away the users in Lille are having an average of 10.5 seconds. And if I simply click on this, it's going to drill me in now just to those users in Lille, and again show us what those response times were as we kind of build this filter out. PBX builds this filter for us. We can see that actually users in Lille were having close to 50-second response times blue indicating again that this was server related. Now, as I scroll down further here, I can see the breakdown of response time by client. So again, there's only 4 of them here, but if this were thousands of clients, I could sort by end user response time, for example, and see that this user at 172.16.2.115 had an average response time of 17 seconds, and 16.1 of those was due to the server delay. Now, this is kind of where we drill in deeper to actually see what that end user experience was, right? So as I drill into this, I can see that we've got a number of HTTP calls. And what PBX is going to do is it's going to show us every single call that user made to this ERP front-end application. And again, I can sort this by page load time, right? So we can see here that for this specific URL, it took 52.2 seconds, right? And if I drill into this a little bit deeper, we can see here that, again, that's indicating that this is server delay, right? So back to the visibility of the east-west traffic, what we're looking at right now is just that north-south traffic, right? So we're seeing that this GET goes out to this web tier for this specific URL, and essentially that server has a 52.2 second delay before it actually responds back to the client. So if I were only looking at this specific front end here, this north-south traffic without the back-end visibility to those visibility gaps for east-west, I may be led down the path of saying, hey, I solved your problem. It's you have a slow web server, right? So in the case of only having that amount of data available, that's really all we have to go on. But with PBX, it is so easy and intuitive to actually get that east-west traffic. What I've done here is I can go in and ask PBX to show us during this time of this slow response to the web tier, what's going on that back end, what's going on the east-west traffic. And again, now what we see is I'm looking at the ERP backend portion of this transaction. And again, I can sort this based on slowest query. So we can see that we've got a number of calls here. Specifically, this one's taking 28 seconds for this specific SQL query to complete, really filling in that back-end visibility problem and being able to come in and actually look at the entire query. And you can see this one here is pretty complex. Execute, stored procedure call, select statement, with all of those different conditionals, the ands, the froms, the inner joins, the outer joins, the wheres, which again is a lot of overhead specifically on that SQL server. But me being a network engineer, from this specific perspective here, what I would do next is actually hand this off to the DBA or the developer and say, hey, look, why is this query so complex? And this one specifically is 8.5 seconds, this one's 28 seconds. That gives us kind of that filling in of that back end, specifically during this time period of this slow front end web call, what's actually happening on the back end. And again, this is kind of a little bit of more of a simplistic 3-tiered application. PBX can do this for 20-tiered applications, right? So this type of visibility is available. And again, being able to quickly deploy those OVAs in that east-west environment and begin capturing literally within 30 seconds and start learning and understanding the end user experience all the way through that application chain from front end to back end. So Yasmin, I'll pause here for any questions.
Thank you, Mike. That was a great presentation. Let me just check for some questions. I have a couple. So the first one is, what virtual environments do you support for east-west?
Yeah, so that's a great question. So today we support VMware as well as Microsoft, and that includes the public cloud as well. So we have capability, and we're on the store for both AWS and Azure. We do also have some other platforms that customers have been able to adapt our image to, specifically support for Cisco ENCS. We have those environments as well, but today officially supported would be VMware or AWS along with Microsoft Azure.
Great. And we have another one. How much traffic is generated from a virtual probe to the data store?
Yeah, so that's a great question, right? And that's one of the key components of what makes us different, right? So if we go back to the slide deck here of where we're showing how we deploy in the virtual environment. Again, as I mentioned, it's essentially a virtual appliance. And one of the things that I'll mention about this as well that I didn't is extremely lightweight, right? So, typically for, deploying and capturing in your ESX environment, it's typically, 2 to 4 gigs of memory, very, very low disk capacity. And then more importantly, that 0.2% of that observed traffic, right? So, depending on the inner VM traffic that you're seeing, it could be, anywhere from, 100 megabit to, 10 gigabit and up. It's very easy to kind of do some of those calculations to say, okay, we're observing this from a traffic throughput perspective between these VMs. And about 2.2% of that is the only additional overhead that we're going to create on the wire. One of the other pieces that I didn't mention prior to this with the actual virtual appliance and from a capture perspective is that we don't charge for this, right? So what we've got, I've got a number of customers that have actually made this part of their standard build for every hypervisor that gets rolled out, primarily because it's going to provide them instant visibility at no extra or no additional cost.
Okay, and we have another question. Is this tool hypervisor agnostic?
Yes, so to an extent, right? So we do today. As I mentioned, we have specific virtual appliance images primarily for Microsoft and VMware today. But as I mentioned, there are other capabilities and future roadmaps to support other hypervisor environments. But today, the officially supported are VMware and Microsoft.
We also have another question. When you mention dedicated 10 gig NIC, does it provide both tap and traditional NIC functions or just tap consuming a port?
Yeah, so typically when I've seen and been involved in these types of deployments, what customers will do is they'll put in a dedicated 10 gig NIC just for the tapping of the traffic, right? So think about if we didn't add an additional 10 gig NIC and we just wanted to roll with the production NIC that happened to be in the hypervisor. With this type of solution, right, this kind of antiquated east-west capture that requires this is anything that you're seeing on that virtual switch. So essentially, in the case of port mirroring, just in the vSwitch itself to a physical adapter, if you don't add an additional dedicated NIC, that traffic is going to be in contention with your production traffic, right? So let's say, a worst case scenario, you've got your 10 gig production NIC and you want to mirror traffic between all of your VMs, and that happens to be an additional 10 gigs, you've then oversubscribed your production network card. So what I've seen in a lot of organizations is that try to deploy this tapping without putting in dedicated tap NICs into the ESX box, for example, is that they'll turn on that port mirror, and then all of a sudden nobody can get to the production systems, right? So there's so much contention for the wire that end user traffic suffers, and to them it's kind of essentially an outage.
Thanks, Mike. We have one last question. And it's, what are the roadmaps to support Zen KVM hypervisor?
So for KVM hypervisor, I can say that, we're definitely looking at KVM. For specifics like that, we can certainly get into time periods and those types of things. We'll probably want to take that offline with your Exedian representative and either myself or another engineer, and we can certainly discuss specifics on time frame. But yes, KVM is definitely one that we've been looking at and have made some advances towards.
Perfect. So that's about all the time we have today. We'd like to thank everybody for joining us, and we look forward to seeing you at our next webinar. Thank you, Mike.
Thank you, everyone.